Alright, I'm trying this again. I've had a lot of problems adding the audio to the video. So rather than going back and doing everything from scratch, hopefully this will be good enough. I'm taking the data from asset allocation data on D2L. I've done the pivot table and I've cleaned things up here, and I've taken out the first few months of GM data because GM from the first part of 2010 didn't have any returns. They had gone bankrupt. They're a private company. Then they came out of bankruptcy and their first return was in December. So I just deleted all that. Is that the right way to do it? Not necessarily, but you don't really use historical data all the time anyway. So like I said, I've already built this sheet out, but I'll just go through here and redo everything. So here is just 12 times the average, and the fastest way to do this equal 12 times, and then take the average, period, control up, go down, close parenthesis, across, copy this all the way across, and then those are my returns. But I would like to have those returns up here somewhere, so I take this, highlight the whole thing here, and I transpose. And the way I did this, start over, well, I'll just do it like I highlight all of these, type equal, transpose, come down here to the bottom, control down, and then press the period, go all the way across, control shift enter, and I have my returns. I need to have the relationship, the risk and relationship, so I go to data analysis. If that data analysis is not there, then go to file, I go to options, I go to add-ins, analysis toolpack, click go, and give me the solver and analysis toolpack, click OK, and then when you go back to data, this should show up. If it doesn't, close Excel and start over. The covariance, so I've already entered this once, so the best way to do it is you just click on the first cell that you want referenced, press the period, go over, then control down. Now you have the entire thing. Labels are in the first row. You want to have your output range, and I'm going to have the output range in the same place that I had before, so click OK. Yeah, it's going to overwrite, so it puts in the data right here. So I'll copy this, and I'll go right over here, paste it, then I'll copy this again, come back here, right click, paste special, transpose, skip blanks, values, OK. I need to multiply this by 12, so I just type a 12, copy this, highlight the whole thing, paste special, then multiply, and then I want to get this looking nice, so I have the data look good, and I don't need this anymore, so clear the contents, and then to get rid of that border, click here for no borders, and then put this border back, just highlight that one row and do the thick bottom border. So now I have the risk and relationship right here, which is the covariance matrix, and I have the returns right here. So now I need to build two artificial portfolios. So to build that artificial portfolio, I just took this whole thing right here, Control C, and just copied it over right there to paste. So I find that easier than retyping all this. I just copy the format as much as I can. So for these weights, I use the formula for the optimal risky portfolio. And the optimal risky portfolio assumes there's a risk-free rate. In my world, it's not really a risk-free rate, but mathematically, to draw the line, I just say, well, what if the risk-free rate was 1%? And when I do that, it's matrix multiply, matrix inverse, and I invert this whole covariance matrix, close parenthesis, comma, highlight the returns, and subtract my artificial risk-free rate, close parenthesis, and divide by the sum, or the entire numerator. Fix that, Control C, come over here, Control V, and Control Shift Enter. And now I've come down here, and when I did this 100%, I just did Alt equal, and that gets us the sum correctly. And then once I have these weights, what I do is I take this and copy and Control V over here. This is by far the fastest way to do it. I take this and just move these references back to where they belong. So it's a little tricky to grab this. I'm working with a laptop and the mouse is kind of a little more difficult to work with. Whichever way you think is the fastest way to do it is the way that you should do it. And apparently this is not necessarily being the fastest way for me right now. But there we go. Now Control Shift Enter. And note those weights are all exactly the same because they have the same intercept, the same constant. Change that to a different constant. And now what I've done is I've collapsed, or I'm attempting to collapse all these stocks into two different portfolios. So Portfolio A and Portfolio B. So what I'm doing here, by the way, is I'm trying to get these 8 stocks into the best portfolio for my clients. One client wants a certain return, one wants a certain risk, and one wants to have the least risk possible. I want to do this and they're allowed to short, and then I want to redo it all and say they're not allowed to short. Okay, so if they're allowed to short, I can use the closed form solution, which means I can algebraically solve for the best portfolio. To do that, I collapse these 8 stocks into Portfolio A and Portfolio B, and I find the risk return and relationship of Portfolio A and B. So the return of Portfolio B is the sum product of the returns times the weights. Doesn't matter which one you put first, and there you have it. The other way you could do this, you could matrix multiply, and you can't multiply 2 column matrices, so you have to transpose one. Doesn't make any difference which one. I'll transpose the weights. I take the weights and multiply by the returns. Control Shift Enter. Do it either way, whichever way you think is the best. So now I have the returns for the portfolio. To get the covariance matrix, the variance is going to be equal to matrix multiply again, and then transpose. So I'm transposing the weights of A and then multiplying by the covariance matrix, close the parenthesis, comma, and then multiply by the weights again. Close the parenthesis, Control Shift Enter. Now the fastest way to do this is to copy and paste and paste. And then rather than retyping all that, to me it's easier just to move this back. And not to A, but over here, I move this over here to B. And that didn't work. Get that one, move it to B, Control Shift Enter. And then here, we're going to have one set of weights go to Portfolio B, the other set of weights go to Portfolio A, and then center that back where it should be, Control Shift Enter. And then this is just equal to that. And now I have a simpler problem. This is like just having 2 risky assets again. So all I have to deal with is the return, risk, and relationship of Portfolio A and B. So we have a client that wants to have a certain return, let's say 25%. Well, the weight is going to be equal to, the way you do this is equal to the return that the client wants, whatever that happens to be, minus the return of Portfolio B divided by the return of A minus the return of B. That's going to give me the weight in A. 1 minus that is the weight in B. And those weights they don't look like they make sense, but you're not trying to make sense of these numbers. This is just 2 artificial portfolios. So now that I have that return, what is the volatility? It's the same thing. It's the square root. And you do this big long number where we have the weight of Portfolio A squared times the variance of A. This is already squared, so you don't square it again, plus the weight of B squared times the variance of B plus 2 times the weight of A times the weight of B times the covariance of A and B, close parenthesis, and that's the volatility. So now I need to find the weight of each individual asset, because this in bold and italics, this is what you tell your client to buy. You know, I have $10 million, so a little over $1 million goes into Bank of America. The way that works is you take the weight of portfolio A, which is an artificial portfolio, lock that down, it's not going to change, and multiply by the weight of AGCO in portfolio A, plus the weight of portfolio B times how much AGCO is in portfolio B, and I highlight the return, I should be highlighting the weight. And that should be it. Come down here, those all add to 100, and I have that percent. So that's my client number 1. Client number 2 is going to want a certain volatility. So we're going to have two different, and I'll clear this off. We have a volatility the client requests is say 15%. And the way we're going to do that, we need to have an A, B, and C because we're solving the quadratic equation. And A is going to be the same thing as the variance of A plus the variance of B minus 2 times the covariance. And then B is equal to 2 times the covariance minus 2 times the variance of B. And you can get this by doing the algebra, which I believe is in a different video. If not, we can do that in class. And then C is going to be the variance of B minus the variance of the portfolio the client wants. That's the volatility, so remember to square that. And these numbers, there's no interpretation to those numbers, so I just want to show enough decimals to see they're not all zeros. And now I have the weights, and note this will change if I want a higher volatility. Those weights change, and I've done the same thing here to get the weights of AGCO. It's the weight in portfolio B, weight in portfolio A times the weight of AGCO in portfolio A, etc. So this weight comes from solving the quadratic equation. So quadratic equation, I'll do that again, equal to minus B. So minus B plus or minus, I'll do plus the square root of B squared minus 4 times A times C divided by 2 times A. And so that's my weight in portfolio A. I'll copy this all over because we're doing the same thing here that we did before, except I need to make some changes. So this volatility in this case is the same as this. This weight, let's look at those weights. I just need to put the A, B, and C back where they should be. And that's going to give me the weights the way I want them. And then the return, or the one difference here, this is going to be minus instead of plus because it's plus or minus. So we have two different sets of values there. And then these weights are going to be equal to the weight in A, and that never changes, times the weight of AGCO in portfolio A, plus the weight in B, and that never changes, times the weight in AGCO in portfolio B. Copy that down, get the formatting to look a little better, see if that adds to 100%. It adds to 100%. And then my return is going to be equal to the weight of this times the return plus the weight here times the return. And again, get that formatting right. And those are right. So I'm not really sure that those numbers are correct yet. I'm going to look at the graph in just a little bit to see that those numbers are right. So what about the minimum variance portfolio? So the equation for minimum variance portfolio is the weight of A is going to be the variance of B minus the covariance of A and B divided by the variance of A plus the variance of B minus 2 times covariance of A and B. So that's just a formula that's given, and then the return is going to be the weights times the returns, and the volatility is going to be the square root of the weights squared, the same volatility formula that you've had before. And then these weights I've already done, those come from the same setup, these weights times those different returns. Alright, so those are my different points, and I think those are right. I've already drawn the efficient frontier from before. Let me get rid of all this. I'll just go through how I drew that efficient frontier again. Start this out at 1. I need to have a different range of weights. I'm going to start with 1 and 0. Let me move that down a little bit. So I want to think about what this point should be. So I mean, if this is 1, this is 1 minus that, right? So think about my step size, and what I want to do is wherever I start, I want to go down from where I started by 1 step, and that step is going to be, I want 100 points in the graph. Why? Because 100 points makes a nice graph. I can pick any number there. The total distance I'm going to travel is from one weight to the next, and I go 100 points. So I just copy that down, and then my volatility is just going to be, and now I'm going back to the covariance matrix for A and B. It's going to be the weight squared. I don't square this because this is already squared, plus the next weight squared times the variance of B plus 2 times the weights times the covariance of A and B. Locking down these, I copy this all the way down. I can double click here and I can see that I'm referencing the right cells. The returns are the same way. The weights times the returns are locked down. So right here these returns are locked down, and so then I graph that, and the graph is going to look like this. And let me see if I can get this up just a little bit. Well, that's just a straight line. That straight line really is not telling me all that much. This is supposed to be a curved line, right? But what I've done, I've zoomed in to one segment of that curved line that makes it look straight, because look at my portfolio A and B. They are pretty much, let me move this over, they're pretty much the same portfolio. There's very little difference. The returns are basically the same. You see 29 to 29.9, so my returns have not changed very much. But if I make that a 2, that changes, that gives me more of the graph. Make that a 3, even more of the graph. 4, I'll go up to 7. Let's go to 10. It's more of the graph. Let's go to 12. And then I'm going to change this to a 5, by the way. And that makes the graph look pretty nice. So you can just mess around with the weighting and with these two intercepts so you get the graph to look the way you want it to look. And I think that looks pretty nice. So now my last thing is just to doing some checks. See if this makes sense. Well, the minimum variance I've told is 13.49. So that looks like it should be right there. 13.5. So I feel that should be right. If that return is 20% and the volatility is 13.98, so 13.98, the return should be 25. That seems like that is working. If we do volatility of 15, then my return is equal to 27.65, and those look like they match up. And let's go here and look at this point, 15% volatility, return of about 15.63, that makes sense. Return of about 27.65, that makes sense. Okay, so I'm going to do the shorting for a different video because I've had so much trouble getting the audio to load.